architecturally design the entire system. We can help you troubleshoot any problems you're having. We support multiple operating systems, Linux, Windows CE, FreeRTOS, Ecos, Microcontrollers. We support all of those out of our Tennessee office. We also offer studio services, which makes us somewhat unique. If you want a very nice user interface, if you don't have a graphics design team, we do. We can be your graphics design team. You can tell us a concept, we can generate some graphics, you can come work in our office with us as we're developing these graphics. They can be 2D, they can be full 3D, we can do movies, animations, anything you'd like to include in the user interface, we can help you do. This is our lineup of graphic MCUs. Starting at the very low end, we would have dot matrix, small dot matrix LCD controls with standard microcontrollers. Then as we move up, we get into small black and white LCDs. We have micros for those. In the middle is our Sapphire offering. That's our full color LCD controller. We have a demo, a white goods demo of the Sapphire on our table. Then moving up, we have a larger LCD. This is a 7-inch design. And then moving to the highest end, this is the 12-inch with a full 3D user interface. It's actually drawn in 3D as we can move those objects around in real time. It takes very little code to get a very nice user interface. So this is our graphic lineup. On the low end, we have Sapphire. It's a 32-bit processor. It's not an ARM part. It's our own core. We designed ourselves. It's very, very efficient. It's designed to drive a 24-bit LCD panel. It can drive up to an 800 by 480 LCD panel. Usually we do smaller panels with it, but it can scale all the way up. Then our standard graphic design, our graphic display controllers are Jade, Emerald, and Triton. Jade is our ARM9 part. That's where we're doing most of our work now. Emerald is our Cortex A9. It's much faster, much more powerful. And then Triton will actually be out next month, and that's a dual-core ARM A9 with dual graphics processors. So each core, the cores can work together, but each core can also talk to its own graphic processor that can run 2 accelerated displays apiece. So you could have 4 LCDs all completely accelerated in real 3D. Then we also offer media processors. We have, our parts are named M10 and M11. It's an ARM9 and a Cortex A9. And the big thing that differentiates a media processor from a graphic display controller is we have video encoders and decoders built into the hardware of the chip. So for set-top boxes, for anything that requires a lot of multimedia, you need to play a lot of videos for a user, these parts can fit in very nicely there. This is an example of a dashboard that we did for Ford. It has 2 LCDs, one on each side. The leaves, Ford did some of the graphics, and then they came to us and said, we really want to do leaves falling down, but we can't do it. We can't make them go fast enough. So we said, okay, fine. It took about 2 weeks, and we completely recoded it, and it took about 200K of code to get the leaves, and they're completely randomly falling and fading in and out as they come down. We designed this board. We call it our PETA board. It has 3 LCDs, all running off of one Jade processor. They each have their own display buffer, and this actually fits in a Ford dashboard for the Ford Fusion. We designed this for Ford as a concept for a next generation. All of this hardware, all of the software was done in our office. This is Ford's electric vehicle. They have, instead of leaves, they wanted butterflies to fly around the screen, and they fade in and they fade out. It's the same thing. It's very easy to do on our Jade processor. This is the Coca-Cola Freestyle machine. This machine is about as tall as I am. It has a full touch screen. It's the size of a 17-inch LCD monitor. So you go up to the machine, you touch what flavor drink you would like, it asks you what you want to add to that drink. So you can have orange Coke, or raspberry Coke, or lime Coke, or there are 125 flavors in that one machine. Coke came to us because they were having a problem with their hardware. They had a design, it wasn't working, it didn't do what they wanted. They asked if we could help. So we met with Coke's executives that day. We drew out a sketch of what they wanted. Tell us the features you want. We wrote them on the board. So we started from this. We formalized it into a block diagram. We took it into schematics. We did the entire schematics for them. We did the board layout. We did an 8-layer board design for them. And then we made the hardware. So we took this entire design for code from concept to hardware, wrote the software, made it work, and delivered them a working product. And to get to, from concept to production, took about a year and a half. Our first prototypes were ready about 9 months after our initial conversations with them. So that's a project that they came to us and said, we don't really know what we want, we just know we don't like what we have. So we help. This is what it looks like installed in the machine. And then that's the machine. Actually, we have 2 of these in our test lab. So we're testing these every day. We built a dedicated test lab for Coca-Cola. So we test their machines on a daily basis. The Sapphire demo that we have set up on our table is a white goods demo that we put together. It's extremely low cost. You see there's very little hardware. We don't need much hardware. Sapphire does almost everything. We give it 5 volts, 3.3 volts. It handles talking to the LCD, no hardware required. It handles the touchscreen. There's no touchscreen controller required. We use some GPIO for communication. The sound, we have some special sound software where we're just using an 8-bit digital port to create all the sound. It's completely digital driven, and we convert it to analog with resistors. The total cost of the circuit is about 17 cents in production, but you get voice quality. You can hear it on the demo. So Sapphire, at our Sapphire demo, the reason that we did it, well, I come from a white goods and appliance background. I've designed appliance controls for many years. Going to a touchscreen is less expensive than mechanical controls. You save money in tooling, you save money in production time. You can have one control that fits in the plastics for many different models in different places. You can get a completely different model simply by changing the software. So you get a lot of hardware reuse that you don't have with a traditional LED-based control. You put voice functionality in. Well, in an appliance, why would you need that? Well, sometimes you need to tell someone to shut the door. You need to tell them they forgot to add soap to the washing machine. Maybe they need to know that their oven's been on for 3 hours and you need to check. So a voice can tell them that instead of a very loud beep. Wi-Fi, we can add a Wi-Fi module to it. When I was designing appliances, we had many people asking for that. Why did they want Wi-Fi? Well, we thought it would be great for collecting usage data. You know, how many cycles does someone run? We could provide software updates. It's not what people wanted. All they wanted was a clock that they didn't have to set. They were willing to pay for Wi-Fi, so they didn't have to set the time on the clock. When we built this demo, we took the Whirlpool logo, we put it across all of these. Our graphics designers came up with these, all of these slides. This is all done in-house. It was a concept we came up with. So these are the kind of things we can do on our Sapphire board. This is our hardware. This is a previous version of what you see over there. We designed that board completely in-house. It's very simple, not a lot of components there. So how do we do all this? It's a lot of work. Well, this is our team. This is our director, and then I'm here. I have 3 people reporting to me. I primarily manage hardware. All hardware designs that we do come to me. I also do support for our Linux BSP. Then we have our director handles a lot of our software. He's an incredibly good embedded software guy. He created the demo on the Jade, the video camera. It's about a 300K code size demo that he came up with. Rick Thiessen, he is our lab manager. He handles all of the code testing. He runs the lab, any testing that we do. Cheyenne Wolford is a very talented graphic artist. He has created animated movies before. He's created a lot of professional graphics, but he works for us. He does any graphics help that anybody comes to us with. Suzuki-san works from our Detroit office. He's our Sapphire specialist. He knows everything about Sapphire. So if I have questions, I go to him. And then we have Tori, and he works actually out in California, and he helps us with user interface development as well. So you'll see that we have a small board plugged into a big board. And that's 2 boards, so that's more expensive than 1, right? Well, not in this case. We created a SOM, the system on modules, very basic. It has our Jade, it has Flash, it has RAM, and it has an Ethernet chip. That's all that it has on the board. The reason that we created that is you can see integrating a SOM into a design, you have to put down 1 connector. It's a 200-pin connector that has access to everything you need. If you don't use a SOM, if you want to do the design completely yourself, we'll be glad to help you, but you have to do your own high-speed layout. The high-speed layout on that board took about a month to do the entire layout and get through signal integrity testing. I had to do that. As a designer, I wish that these modules had been available to me because they save, that's 1 month off of your project. You're already 1 month ahead of the schedule. Flexibility, but they're very flexible. The ultimate flexibility is to design your own board, but we offer SOMs that are medium, they're the high end, the medium, and the low end. So if you design a board and you need to cost it down, make it less expensive, you can put in a less expensive SOM. If you design a board and you're not getting enough performance or you need to add a feature, put in a different SOM. You don't have to change. You don't have to change your high-speed design. It's very, very fast to switch. It also gives you the option of having 1 baseboard that can go with multiple products. You can change the SOM to be appropriate for that product. So maybe a low-end dishwasher or washing machine and a high-end washing machine. They could have the same control board. You just change the SOM and change the cost to be totally unique. Layout, if you wanted to do a board with 2 layers, you could. You can plug the SOM into a 2-layer board. If you want to lay out your own, it will take you a minimum of 4 layers, but realistically 6, just to do the layout for the memory. Signal integrity, we've done that. The SOM, we've already done it. We know it works, we've tested it. So that takes that test time off of your schedule as well. If you don't like using VGAs, some people don't have processes, manufacturing processes that can use a VGA. But if you use a SOM, you don't need to use a VGA. For hardware upgrading, it's easy. Put it in your SOM, done. To bring it up, the SOM that you'll get comes with a bootloader. It's already installed, so all you need is a serial port, and you're done. We support, our VSPs support many, many peripherals, and if they don't support one you want to use, contact us, and we'll be glad to help you with that. Time to market, you're halfway done. You use a SOM, you're halfway done with your project. All you have to do is decide what you plug into. The NRE cost, well, you're much less likely to spin multiple boards because you're having test failures if you use an already approved SOM. The design risk, it takes a lot of risk out of your design. You don't have to worry about, is my memory going to work? What if my manufacturer changes PCB material and they don't tell me? This doesn't matter. Everything outside of the SOM can be low speed. future-proof design. We have plans to produce SOMs for chips that are on the drawing board now. So this is a strategy that Fujitsu is committed to long-term. So as we release more powerful chips, there will be a SOM that comes out with it, so you can start testing it immediately. The connector we use, we chose a standard SODIMM connector. Why did we choose it? Well, we need at least 200 pins. This is a 200 pin connector, and it costs well under $1. It's the least expensive option we can find, and it's very secure. Some of the things that we bring down on those 200 pins, we have a 24-bit LCD interface. We bring an 8-bit video capture in. We have Ethernet. We have multiple I2C channels. We have 6 UARTs. We have serial ports. We have SD card interfaces. We have USB, 2 CAN channels. We bring the entire parallel memory bus down if you decide you need to expand the system. I2S for audio. We can support both input and output. We have 2 native A to D converters, 2 PWMs, 4 hardware IRQ lines, a DMA controller if you need very high-speed data access. We have some GPIO. All we need is 5 volts and 3 volts, 3.3. That's it. So the SOMs that we have planned is we currently have a Jade SOM that you can see today. The Emerald SOM will be finished by the end of next month. When Triton is released, we'll have the SOM for that ready. Then the M10 and M11 will follow on. All in the same family. They all have the same pin out. They're all interoperable. So the Jade SOM specifically, Jade is an ARM9 processor. We have 128 megabytes of RAM on board, 32 megabytes of flash. So it's an entire self-contained system. The graphics accelerator inside this chip is fully accelerated 2D and accelerated 3D. So this can do some very amazing things without touching the processor. The demo that you'll see with the video input, the processor is actually idle. It's not doing anything at all. The graphics accelerator is handling all the video capture and putting it on the display and blending it with the bezel. We have USB coming off of this part. We have SD card. We can boot off of that SD card. If you want an embedded system with 16 gigabytes of memory, we can do that with the SD card. Then we bring down all of the standard interfaces that you're familiar with talking to. So, some example of customer implementations. What are we doing with these? Now, this is a Jade SOM design that we're working on right now. We take our standard SOM and we're connecting all of these peripherals to that one SOM. And we can handle all of this item. So, why did we come up with the SOM concept? Was to make our parts easier to use. If our parts are easier to use, we'll sell more. That's good for us. Easy to use is good for you as an engineer. So we have the idea to put everything you need in one box, called an idea box. It has an LCD, it will have the board, it has a USB drive, and that USB drive has the schematics, it has the board layout, it has the Altium project files, it has all of the DSP source code, it has the bootloader source code, all the app notes we have related to that part. Everything you would possibly need to get started is right there in your hand. You don't have to go look it up on the internet. You get the power supply, and you get a JTAG programmer with the J board as well. So everything you need to get started, bring a laptop, connect it up, and you're moving. So for IdeaBox, we're going to bring out IdeaBoxes for 4 of our MCUs. Sapphire is our graphic MCU. That's the first IdeaBox that we'll have ready for production. So what you see on the table is exactly what's going to be inside that IdeaBox. For the SoCs, we're going to have Jade, Emerald, M10, and M11 IdeaBoxes. And all of those will be complete. If you order one, you get everything you need to get started. Jumpstart is what we call our USB drive. And this is all the information that we're going to have on there. There's everything. There's not anything that you would need to go look for to get this system up and going, compiling code, running, programming, you name it. The Sapphire Idea Box specifically will have our board that you see. It will have a micro SD card to go in the interface. It has a USB port for connection to your computer over serial. It has an LCD with a 4-wire resistive touchscreen. It has a speaker. The speaker is connected directly to Sapphire. We don't use any expensive hardware. It will have the Fujitsu ICE. That's our debugger. It will have a power supply, USB cable, and the USB drive to contain the IDE, the compiler, everything you need. The Jade Song is the carrier board that you'll see over there. We give you 4 video inputs. You can connect 4 cameras at one time to this board. Look at all of them. You can connect 2 LCDs to it. The headers are there. It will run 2 LCDs independently. It has an HDMI output if you just want to plug it into a monitor, if you don't want to have an LCD. Audio input and output, you can plug in headphones, speakers, microphone, it's all to the system. A micro SD card that will have operating systems on it that you'll be able to choose what you want to see. It has USB, Ethernet, serial debug, all the standard buses come out to pin headers, so you can solder to them very, very easily. And we're also including some demos of some graphic design software. So you have this great chip that will run LCDs, but you need to create the content. But we're going to include demo versions of some tools so you can do that. Also, you'll have a 7-inch LCD with the Jade, and it has a resistive touchscreen as well, and then the program. Emerald is exactly the same. We're going to use the same baseboard. It's a song. We take the Jade out, we put the Emerald in, and we're done. So, how else can we help customers? Well, we talked a little bit about design services. These are some of the customers that we've actually done work with. They've come to us and said, we have a problem. We need help doing something. So we said, okay, let's see how we can help you. So we've done successful projects with all of these companies. What do I do? These are specifically the things that I help with. We decide what hardware features you want. We do schematics. We do layout. I can help you get boards. If you want fully populated boards, we can have those delivered directly to you. If you want boards that are tested, we can get the boards, we can do the testing, and then when you get a board, it's a ready-to-go product. As much involvement as you want from us, we offer through our design services. As for software, we'll do as much software help as you want, or as little as you want. We've supported all of these operating systems before. We'll be glad to help with anything you have. And software quality. This is something people don't seem to pay a lot of attention to, but it's critical to a good design. Especially a design that has to be certified for software safety. There are ISRA standards for automotive. We can help with those. IPA is a group in Japan that we've worked with before for code verification. Automotive SPICE is used in the automotive industry. That you have to start at the very beginning of your project and document everything in automotive SPICE. Some of the tools that we've used. PC Lint, I use that on every project I do. That's mandatory for me. MicroTool, we've used a MicroTool for automotive SPICE. PRQA, we've used for code verification. Understand is a very good tool for code analysis. And then we actually have our own tool called PG Relief that we're now marketing in the Americas. PG Relief will do everything that these two tools do together. Our studio services that we offer, well, we've done Harley-Davidson demos, we've done Ford demos. You can see that the objects here are full 3D objects. These are 3D design tools. This is 3D Studio Max. So you actually take 3D objects and put them on our processor. So you can move those around, you can scale them, you can change your lighting, change colors, and you don't have to redraw anything. Tell the graphics accelerator, this object needs to move this direction, 10 units, and it moves. That's it. It's very, very efficient. The only problem we have is, customers will come to us with this really nice looking bezel. Well, it's 12,000 triangles to draw that. That's not very efficient. So we can help them. We take the same bezel and draw it with 250 triangles. It looks exactly the same, but it's much faster in the process to draw it. This is another example of optimization that we did. We took a speedometer needle that's 4,000 triangles and reduced it to 68. It looks exactly the same, only it's much more efficient to draw that and to move it around the screen. Some of the design tools that we've worked with for creating user interfaces for customers. EV Guide is very popular in Europe, especially in automotive. We've used that. We have our own tool called CGI Studio that's fairly new. It's a very, very powerful 3D user interface design tool. Crank Software, we support them. They support our chips fully. They're both 2D and 3D user interface design. And then Altea. Altea is big in the United States in the automotive market. They support our parts. But this is the interface to CGI Studio. You can see on your computer what your user interface will look like in real time. You get exactly the same performance on the computer that you would see on our Emerald or on our Jade chips. We designed it so that you don't get any extra acceleration from the computer. It performs, the graphics and the performance is exactly the same. So you know what you're getting before you ever put it in hardware. So inside CGI Studio,